Hello there. We're going to take a look at vectors day 2. Today we're looking at unit vectors. We're going to take a look at the angle of a vector. And I don't remember. We got a word problem at the end too. So to find a unit vector, what you're going to do is you're actually going to take the vector itself and divide it by its magnitude. Okay. So remember, magnitude from yesterday is basically just the square root of a squared and b squared. So to find, let me shrink this a little bit so I have some space to work. We're going to find the unit vector that has the indicated direction as the vector v. So we want, what are we doing? Wrong thing. We want the unit vector of v going in the same direction as v. So what you're going to do is you're going to find the magnitude of v first. And then, of course, that is the square root of 2 squared plus 0 squared, right? Because this is really technically 2i plus, that I should be there, plus 0j. So it's 2 in the vertical direction, 0 in the horizontal, nope, sorry, wrong way. 2 in the horizontal direction and 0 in the vertical direction. So, the magnitude of v is going to be v. So what we do is take the unit vector will be 2i over 2. And it's in the same direction. So this is a positive 2 there. So we just stay with the positive 2. So that's just an I. And really what it means is, guys, if I graph this, so my original vector was literally just 2 units out, right? Oopsies, that arrow should be closer there. There we go. Okay, so 2 units out. And so then the unit vector is just 1 unit out in that direction. Okay, so it's going in the same direction and it's just 1 unit. Okay, we now want a unit vector in the opposite direction of v. Again, you've got to find the magnitude first, right? So the square root of negative 12 squared plus 5 squared, right? And when we do that, we get a 13. Okay, and so the unit vector for this, when we do this, when we write this out, our unit vector is going to be, now we're going in the opposite direction. So what I'm going to do is I'm going to change these 2 signs. So it's going to be a plus 12i and a minus 5j. Okay, and I'm going to put that over, whoops, where are we going? Sorry. We're going to put that over our magnitude of 13. Okay, and so the unit vector is actually going to be 12 over 13i minus 5 over 13j. Okay. All right, so what we have to do is use this formula up top that's highlighted, the magnitude of v times the quantity of cosine theta times I plus sine theta times j. We're going to use that to write a vector in a form, in our standard form. Remember, there's multiple ways you can write vectors. Don't forget we could do like this, right? But this is basically our standard form. Our component form is what it's called, because then you have the horizontal component and the vertical component. So you know what your 2 components are. So we are given the magnitude and the angle it makes with the positive x-axis, okay? So basically, this one, if we looked at it as a drawing, right, it would make a positive angle with the x-axis, like that would be 60 degrees, and our magnitude would be 13 for that, okay? So what we're going to do is we're going to do, and ultimately, guys, this whole formula comes into play, guess what? Right triangles, yay! Like, they show up everywhere because, you know, it's trigonometry. So it's going to show up all semester. All right, so literally all you have to do for this is take your magnitude. I'll try to color code it so it looks a little nicer. 13 times the cosine of 60 degrees, okay, times I. Now, it's important that you don't like try to type in cosine 60i in your calculator, plus sine of 60 degrees. Oh, I didn't know I should. Okay, never mind. Sorry, I'm not working well with the pens this morning. I should say. All right, so then when you do this, this is just going to be your 13 times the cosine of 60 is 1/2 I plus the sine of 60 is radical 3 over 2 j. And then you just distribute your 13 across. Please stop that. Okay. So then it's 13 halves I plus 13 radical 3 over 2 j. Okay, so you're just writing it in the component form given the magnitude and the angle. And you are literally just using that lovely formula up there. Just another one for practice. The reason I threw this one in there is because it's 220 degrees and 220 degrees is not on your unit circle. So you are literally just going to use your calculator for it. So when you're doing this, you've got the magnitude of 3 times the cosine of 220 degrees times I plus the sine of 220 degrees times j. And so it's going to be 3 times, and cosine of 220 is roughly negative 0.77 times I plus the sine is negative 0.64 times j. And so when I'm rounding, I'm just going to round to the nearest hundredth. Please pay attention to what my math lab wants you to round to and go out to that. So minus 1.92 j. Okay, so you don't always have to have it on a unit circle. You can have basically any angle, really. And honestly, in real life, you don't actually have angles that, work out nicely on the unit circle. So just one to show you that, yes, you could just use your calculator for it. Oh, make sure your calculator's in degrees. All right, we're going to find the direction angle of the vector. So basically we have a vector, and if I were to draw this vector, remember this is the horizontal, this is the vertical. So basically it means I'm going 5 to the right, 5 down, and now ultimately, guys, the vector would be this arrow. So that's, we're starting at the origin, we end, and this is, we would find our magnitude. Our magnitude would actually be 5 radical 2. But what we want to do is we want to find the angle that it makes with the positive axis, the positive x-axis, I should say, which is technically the positive y-axis, because really, well, it depends. It just depends on what plane you're thinking of. So when you do this, you're just going to use the fact that you've got a 5 here and a negative 5 here, and you're going to straight up use tangent. Tangent of theta equals opposite over adjacent. So inverse tangent is going to be, inverse tangent of negative 1, is going to be the theta, and your theta is going to be negative 45 degrees. And you go straight to your calculator, plug that in, right? Or negative pi over 4. Again, just look at MATLAB, and if it asks for degrees, please enter in degrees. If it asks for radians, please enter in radians. And you don't have to draw it if you don't want to, because it's always just going to be the b over the a and using tangent. But it's nice to draw it because, remember, sometimes your calculator gives you an angle that you think works, but it's in the wrong quadrant. So you either have to add 180 or sometimes it wants it in a positive angle. You've just got to follow the rules of each problem. All right, so if I were to draw this one, I would head 1 to the left and 3 down, right? Well, that's not drawn very well, okay? And so then this would actually be my vector, right? Because this was my component form, but that is actually my vector. And so negative 1, negative 3, so we do inverse tangent of that. Opposite over adjacent, right? So inverse tangent of 3 equals the theta. So here's the deal. When I plug this into the calculator is going to give me 71.6 degrees. Well, 71.6 degrees is up here, right? But that's not the angle that I want to be. That's first quadrant. That's not where I want to be. So I have to add 180 degrees to get to the quadrant that I need to be at, which is the third quadrant. So it's really 251.6 degrees, right? So again, it takes an extra 10 seconds to draw it, and it's just kind of nice to have it drawn so that you can see what's really going on. All right, two forces, F1 of magnitude 35 newtons and F2 of magnitude 55 newtons act on an object at angles of 45 degrees and negative 60 degrees respectively with the positive x-axis. Okay, find the direction and magnitude of the resultant force, that is, find F1 plus F2, and round the direction and magnitude to 2 decimal places. So what you're going to do, right, here is your positive x-axis, right? You've got a force of 35 newtons acting at 45 degrees. So you've got this right here, right? This is 35 newtons acting at 45 degrees, right? You have a force of 55 newtons acting at negative 60 degrees. So this guy, and these are obviously not drawn to scale, is right here. Sorry, 55 newtons, acting at negative 60 degrees. Okay. So now remember, when you do F1 plus F2, when you're adding vectors, right, this blue vector that I just drew, and I shouldn't be using arrows because it's going to get us confused. I can also, like F1, like the first vector plus the second vector, I can actually, what I end up, when I'm adding vectors, my first vector starts here, ends here. To add the second one, I'd really start where the first one ended and would draw it over here. Okay? So what you're trying to do is, like, basically, when you see it drawn, it would usually be dotted lines. That's terrible. Dotted lines are so bad. But it would be the same direction and same magnitude, so same length and everything like that. And what ends up happening is your resulting vector is right there, F1 plus F2. Okay? So that's what we have to find. What we need to do is we need to get each of the vectors into component form. So we need to get them into our component form. And what we're going to do is use the formula from, the previous two examples. So when we do this, the first force vector is 35 newtons, because that's our magnitude, times the cosine of 45 plus, I, plus the sine of 45j. Okay? And I just work with decimals, guys. Just run everything through with decimals because it's just actually a little bit easier. So 24.75 I plus 24.75 J. Although I think my math lab might actually leave it. We'll see. I don't think so. I think I took that problem out. So then we've got the second one is 55 cosine of 60I plus sine of 60J. So that's going to be 27.5I minus 47.63J. So F1 plus F2 all you do, remember, when you're adding vectors that are already in component form, you just take A plus A, B plus B, okay? So 24.75 plus 27.5 is 52.25 I, so that's my A component, and then 24.75 minus 47.63 is the B component, and so that's going to be minus a 22.88J. So that is your resultant vector, okay? And we want the magnitude of that, okay? And remember, magnitude is just the square root of A squared plus B squared, so 52.25 squared plus a negative 22.88 squared, right? And so that's going to be 57.04 newtons. Whoopsies. And then if I want the actual, I want the direction of that with respect to the positive x-axis, and I'm sorry guys, I gotta shrink this a little bit because I need to write down at the bottom. When I do this, all I'm gonna do, tangent of theta equals b over a, right? And so that means my theta, when I plug that into my calculator, inverse tangent of that fraction gives me negative 23.65 degrees. So that means this angle right here is negative 23.65 degrees. Okay, so you found the angle and the magnitude.